Hello everyone. Let's get started again. Um, Last video, we stopped at this point. I defined the cross product of uh, base vector. Also, I reminded you the dot product of base vector what you have discussed. So now I'm going to extend our discussion further uh, to explain, to understand the vector, right? So then general vector. Then how can we represent any vector in terms of our base vectors, right? Okay. So for that, let me consider the axis system this way. I'll use different color. Okay. Let me, okay. Yeah, it's fine. Right. So now, this time, let's say this is our O, x1, x2, x3. It should follow the right hand rule, right? Okay, yeah, it follows. Right. So also, we discuss uh, the base vector, right? So each axis, we have a base vector along each axis, right? E1, E2, and E3. Okay, so this is your E1, E2, and E3. Okay, so now let me consider another system to represent a general vector. Okay, so let me erase this one. Let's put our vector point O. Okay, so now here, let's consider a vector. Vector, we need one reference, frame of reference. From that frame of reference, we represent the vector quantities, right? So let's say this is our vector. Okay, so this vector, it has, let's take a different color. Okay, I'll use different color for the vector because we will be consistent, right? Our colors and everything. Okay, so this is the vector. Now let me take red color again. So this vector, first I can project along this face, this vector projection. Okay, so this one actually the projection of this vector on x1, x2 plane. So then I can decompose this vector into here as well as here, right? Okay. So now this vector has one component along x3, x2 axis, x3 axis. Then similarly, you will have the component along x3 axis, right? Yeah. So like this. Now you have to imagine this one, right? So this vector, let's say this vector is v. Then each vector make the component along x1 axis, that is v1, v2, and v3. Okay, v1, v2, v3, it's a magnitude. Magnitude of this vector components along this axis, right? Okay, so if you want to make this one as a vector, this v2 is the magnitude, right? Okay, so now this vector v, how can you represent vector v? We can represent as in terms of these vector, right? How can you make in terms of these vector? v1, this is the magnitude. Direction, we need the direction. Direction is e1, right? Then magnitude and direction. Okay. Similarly, plus v2, v2. Y plus, it is a resultant, right? You know, it if it is two dimension, you can see these two is a parallelogram. It will align with this diagonal, the resultant. Then this result, I mean this one and this one makes the parallelogram. Therefore, this will be the resultant for V1 and V2. Then this resultant and V3 will give you the V, vector V, right? So again, we are using the parallelogram. Okay, right. Okay. I think if I make this one V3 in this way, it is making, yeah, I will draw V3 this way, right? So now it will give you clear picture, right? Parallel to this. Okay. Yeah. So this is your V3, right? Yeah. So now I think you can imagine. So this one also one parallelogram, right? Okay. Yeah. So that's what I am adding. Then V1 plus V2, actually I am getting this vector now. Now this one is actually this, right? So I'll put this one is V dash vector. So this is actually V dash vector, right? Now this V dash and V3 now makes the parallelogram. Now this is the resultant, right? So therefore, I have to add these two, right? V1, V dash and V3. So that is V3. Okay. So now this is your vector. Okay. So this is the way we represent one vector in terms of the base vector. Again, we know we use index notation. So what is the index notation for this vector? Okay. So first I will write the right side part. Right side part, you know, V1, V2, V3. Therefore, I can represent Vi. Again, summation is there. Plus sign is there here. Here you have plus sign. So therefore, we have to follow the summation convention. That means we have to repeat I one more times, right? Vi. But you must apply, you must say this one is the vector, therefore it is vector, right? Okay. So sometime student will confuse. How they confuse? Because here I is repeated more than once, they consider it is a scalar. No, it is not a scalar because this is base vector, right? This is the vector. So therefore, the final quantity is the vector. This is the directional component, right? Component of the vector along each axis. So this is EI is the base vector, right? Unit vector. So now you have to make consistent this equation, right? How can you make consistent? Then this side I is a free index. Then forget about this vector. So I is a free index here, right? Because this is the direction, right? We consider the magnitude now. Then here I is a free index. Therefore, this side also we should give the notation in terms of this free index, right? So that means bi. Okay. So this is the way we represent the vector, right? So this side is the same. So this is the way we represent any vector in terms of index notation. Okay. Right. So now let's take two vector, right? So let's take vector A as this way in terms of index notation, right? AI EI, right? Now, similarly, let's take another vector B, BI, EI, right? Okay. Right. So now what I am going to do, I am going to write crux and dot product, right? So that means first one, I'm going to define vector A dot vector B. So you remember A dot B and B dot A is same, right? Okay, we can write that one. We can prove that one using these two equations, right? So let's see. Let's write A in terms of index notation, right? AI, EI. Okay, dot. Now, again, BI, EI. You cannot write BI, EI here. Why? There is a rules. We studied these rules, right? Then I think very first video, we discussed some rules, right? Okay. Repeated index cannot be repeated more than 2 times. Cannot, right? I think I have written as can. It should be cannot, right? Okay. Cannot be repeated more than 2 times, right? Okay. So that means here, if you write it as BIEI, I repeated 4 times, right? It is wrong. So therefore, we have to write this one. We have to change this sign in different notation, right? BJ and BJ. Okay. So why I am writing J, both J? Because because BIEI, if I change this one, then this one also automatically change, right? So that is what? BI, BJ, EJ, right? Okay. So now, so let's combine together. Now, this AI and BI just a number. That is just a scalar. You can take it out because these two are the vector. EI and GEJ is the vector, right? So these two, it's a normal multiplication. Therefore, you can write it EI, BJ separately. So now you have, I'll put the bracket, EI dot product with EJ. Okay. So now this is AI, BJ. This is already we studied, right? Dot product between two, this one. This is actually our Kronecker Delta, right? Delta IG. Okay. So now, again, we discussed the properties of Kronecker Delta. What is the properties of Kronecker Delta? You have to select. You can select I or J. In this case, if you select J, J is here, J is here. Now you have to replace this J with the another indices in the Kronecker Delta, right? Now you have to replace with I, right? So you could remember these properties, right? Yeah, this property, right? We discuss this property. So I am applying the same properties there, right? Okay. So now I am up. If I apply the same property here, now I will get AI. Now B, instead of J, I have to replace with I, right? Okay. Now this is the final answer, right? So that means vector A dot vector B, it is actually AI, BI. What is AI, BI? Then if you have repeated index, you could remember summation conversion, right? So therefore, I goes to 1 to 3, A1, B1 plus A2, B2 plus A3, A3. So this is something you studied in your mathematics, right? So dot product between two vector, just individually multiply, individually get the product of E components and get the summation, right? And product summation is the answer, right? The same thing we are getting here, right? So you can do the same. If you apply B dot A, again you will end up with the same answer, right? You can try. Okay. So now first I explain the dot products, right? Okay. Now let's go to define the cross product, right? A cross B. Okay. So now A, AI, EI, you can write is a vector cross B, J, E, J. Why I am changing J? Again, the same rule. I cannot repeat more than, cannot be repeated more than twice, right? Okay. Okay, so now these two same, right? These two is a normal scalar, just is you can multiply is normal way, right? EI, BJ. So now here EI cross EJ. Okay. Now AI, BJ. Now you could remember this one. This is belongs to, this is what we studied, our permutation symbols, right? This one. Okay, so this one will be epsilon I j k e k. Okay, so this is the cross product of the vector. Okay, so now if you expand this one, right? If you expand this one, the ijk, there's a rule, right? If it is a clockwise, it is 1, anti-clockwise, negative, right? If you expand this one, then you will get finally, I will write the final answer. Then you can try, right? Uh, uh, I can explain, but it's unnecessary because I already explained you the procedure you have to follow this one, right? First, you have to substitute I, then J, and finally K, right? Okay, or else I will explain here, right? For one. Then first, I will substitute with K, right? Uh, okay, instead of K, let's substitute with what shall we do the first? Okay, I will substitute with I first, right? I 1 to 3, right? Because I repeated more than one, the summation conversion is there. A1 Bj epsilon 1 Jk Ek plus A2 Bj epsilon 2 Jk Ek plus A3 Bj epsilon 3 Jk Ek. Right. So now the I have done for the I, right? Let's do it for J. Okay. So here I'm going to remember these things, right? I'm going to use this one, right? That means ijk this way is +1, then opposite way is -1, right? Okay. So now any other order, it's 0, right? If I substitute, when I substitute for J, let's say B1 epsilon 1 1 K. Okay. So for example, here, the first part only I will write here, right? I will write it in a separate color here. A1, when I substitute J equal 1, B1 epsilon 1 1 K EK. So now, no need to worry about K. K can be anything, but it's not following this order, right? 1 2 3 1 1 mean it is 0. Okay. So therefore, the J equal 1 is not applicable here. Okay. So now J equal 2, I can put, right? So A1, B2, epsilon 1 to k ek. Right? Similarly, j equal 3 also I can put, right? Okay. So a1 b3 epsilon 1 3k. Okay. Right. So now plus this one, right? For second one. When I substitute 1, I can get, right? 2, 1. So only 2, 2. When I substitute 2, 2 to k. So it will be 0, right? So therefore, no need to consider that term. Then I can write 1 and 3, right? A2, B1, epsilon 2, 1, k, ek. I'll write here. Then A2, B3, epsilon 2, 3, k, ek. Right? Okay. So then, okay, so now the second term is done. Then go to the third term, right? A3, B1, epsilon 3, 1, k, ek plus A3, B2, epsilon 3, 2, k, ek. Okay, so now A3, when I substitute A3, B3, 3, 3k, that 3, 3 is 0. Therefore, I have not considered that term, right? Okay. So now, let's consider, now I am going to substitute k again. Now again, what is that? Repeated index, right? Because k is repeated, therefore summation conversion is applicable, right? So I have to substitute k 1 to 3. Okay. So first, when I substitute k equal 1, I will write here, but I will get a1, b2, epsilon 1 to 1, e1. 1 to 1 is 0 because 1, 2, 3, it must follow this order, right? So 1 to 1 to 1, it's not following the clockwise order. This is 0, right? Similarly, when I substitute 2, 2 also 0, 1, 2, 2 also 0, right? So therefore, K1 and K2 is not applicable for first part, right? First portion. So therefore, only 3 will be there, right? If A1, B2, epsilon 1, 2, 3, E3. Okay. So now this part is done because I consider K1 to 3. Then I am going to the third part, right? 1, 3, K1, 1, 3, 1, 0. Then 2 will be there, right? A1, E3, epsilon 1, 3, 2, E2. 1, 3, 3 is 0, epsilon 1, 3, 3 is 0, right? So therefore, I don't need to worry about that part. Then I will consider the third one, right? Because I consider 1, 2, 3 for second term. The third term similarly, 2, 1, 1, 1, 1, 1, it's not applicable, 0. 2 also not applicable, 3 will be there, right? A2, B1, epsilon 2, 1, 3, E3. Okay. So now the third term is done. Now I'll come to this term, right? Okay. So now 2, 3, 1. 1 will be there, right? A2, B3, epsilon 2, 3, 1, E1. Okay. 2, 3, 2, 0. 2, 3, 3 also 0, right? Okay. From here, 1 not applicable. 3 epsilon 1, 1, 0. 3, 1, 2 is there. 2 is there, right? A3, B1, 3, 1, 2, E2. Then 3, 1, 3 is 0. I no need to worry about it, right? Here, when I substitute 1, 1 will be applicable. 3, 2, 2, 0. 3, 2, 3 also 0, right? So therefore, only 1 will be there. A3, B2, epsilon 3, 2, 1, E1. Okay. Right. Now, okay, I will write it one more time here. 1, 2, 3, right? You have to follow this order, right? If it is this order plus 1, the opposite order minus 1, right? Right. So 1, 2, 3, follow this order. Therefore, this one is 1. Then here A1, B2, E3. Okay? Plus. So now 1, 3, 2. 1, 3, 2, it's opposite order. Therefore, minus 1, right? So minus I can take it front. So I can write it A1, B3, E2 plus. Now this term 2, 1, 3. 2, 1, 3 again the opposite order minus 1. Therefore I will take minus here. So this is A2, B1, E3. Here 2, 3, 1. 2, 3, 1 plus 1. So therefore plus A2, B3, E1, right? Okay, this term, right? Plus. So now I will write it this term, right? Okay, 3, 1, 2. 3, 1, 2 again the clockwise, therefore plus 1. A3, B1, E2. Okay, 3, 2, 1. 3, 2, 1 is minus 1. Therefore, A3, B2, E1. Okay. So now what I'm going to do, I'm going to combine the E1, E2, E3 terms, right? So let's combine E1 terms. So I'll get A2, B3 plus A3, B2. I can take E1 out, right? Plus. Similarly, E2 terms. If I take E2 terms, this one, I'll take minus out, right? Then A1, B3 minus A3, B1, E2. Then finally, the E3 terms, E3, right? A1, B2 minus A2, B1. Okay, right. Okay, so now you see this is the vector, right? E1 component, E2 component, E3 component. This is like a vector, right? Like this way. This way, right? V1, E1, V2, E2, V3, E3, right? Okay. So this is actually your V1 component, V2 component, and V3 component. You studied the same thing you studied in your mathematics, right? Then the cross product. This is actually, you can write it this way, right? The determinant E1, E2, E3. Here A1, A2, A3, B1, B2. Actually, this equal to this one, right? Okay. The same thing you obtain here. You see, rather than writing this much of long expression, simply we write this one, right? I think rather than writing this much of long expression, simply we write this, right? So this is the benefit of our index notation, right? Okay, right. So in this video, we discussed two things, right? One is any dot product between these two vector, it is actually AI, PI. Then cross product between two vector, actually AI, BJ, epsilon IJK, EK, right? Okay, yeah. So these two only we discuss here, right? So very important conclusions. So in next video, we will do some of the questions, right? By applying our definition, then cross product and dot product, the substitution techniques, right? We will try to discuss some of the questions, right? Right. So please subscribe and share with others, right? If you have any question, just put it me in the comment section, then I can, help you, right? So I can go through and help you if you need further explanation, right? Okay.